What's pictured here on the right is often referred to as the Bohr model of an atom. In the Bohr model, protons and neutrons occupy the center nucleus of the atom, and electrons will circulate around the nucleus in one of several energy level shells. So there are two types of particles that we can find in the nucleus. Protons, which are positively charged particles, we can also see what are called neutrons, and these have no charge. And in the shells, we find electrons having a negative charge. This atom here is a calcium atom. And if we go to the periodic table, we can see all the different atoms that have been discovered so far. Here is the periodic table of elements. And calcium is just one of the atoms right here. It is the 20th element in the periodic table. The 20 in the lower left is called the atomic number. And that tells us how many protons an atom of calcium contains. As you'll see in the periodic table, they are organized by atomic number, starting with the first element being hydrogen, which contains only one proton. Then we would read it from left to right, and we see that helium is the next element, having 2 protons in its nucleus. Next comes lithium with 3 protons, beryllium with 4 protons, boron with 5, carbon with 6, nitrogen with 7, oxygen with 8, fluorine with 9, neon with 10, sodium with 11, magnesium with 12, aluminum with 13, and so on. Eventually, we get to calcium, which has 20. So it's a relatively large atom compared to hydrogen and helium. So, from the periodic table, we can determine that 20 is the atomic number for calcium. And all calcium atoms have 20 protons. Calcium is just the name given to an atom of 20 protons. So, what is an atomic symbol? Well, the atomic symbol is the letter or letter combination that identifies the atom. So here, Ca is called the atomic symbol. (20) is the atomic number. And if we look in the upper left, we see something called the atomic mass, which we'll use here shortly. But the name calcium and atomic symbol Ca is reserved for any atom of 20 protons. This brings up the question, how much charge does a proton have, and how much charge does an electron have? The charge on every proton has been determined through experiment to be 1.6 times 10 to the minus 19 coulombs. They all have the same charge. This number is so important in physics that it's been given the symbol little e, which stands for elementary charge. An electron has the same size of charge, but it's the opposite sign. So an electron will have negative e. Negative 1.6 times 10 to the minus 19 coulombs. Neutrons, on the other hand, are totally electrically neutral, so they have a Q of 0. In order to find the total charge on a group of protons, we simply need to multiply the number of protons times that elementary charge. Masses of subatomic particles are given above. The mass of a neutron is 1.67493 times 10 to the negative 27 kilograms. Mass of a proton, 1.67262 times 10 to the minus 27 kilograms. So there's a little bit of difference there. A neutron is slightly heavier. And the mass of an electron is much smaller, 9.11 times 10 to the minus 31 kilograms. Let's find the mass of a calcium atom, which has an atomic number of 20 and a mass number of 41 in the upper left. So the mass number in the upper left is the sum of protons and neutrons. Okay, that's going to be the 41. And then down here we have simply the protons. So let's do a multiplication. I'm going to multiply the number of protons times the mass of a proton, and then I'm going to add in the number of neutrons times the mass of a neutron. All right, so we're going to need 20 times 1.67262 e minus 27. And how many neutrons do we have? Well, the number of protons plus the number of neutrons here is the atomic mass number. So with that in mind, we have 41 equals 20 plus the number of neutrons. So the number of neutrons is 21. All right, let's add these things up. I get 6.847 times 10 to the minus 26 kilograms. Next, an ion is an atom or molecule with a non-zero net charge. We want to calculate the net electric charge on a calcium atom, which has an atomic number of 20, a mass number of 43, and also a charge of +2. That's what goes in the upper right, is the net charge on the atom. But that is not in coulombs, it's in elementary charges. So +2 just means that this atom has 2 more protons than electrons. So the net charge of this ion is +2 elementary charges. The atom has how many protons? That's always given in the lower left. In fact, an atom can't be called calcium unless it has 20 protons. How many electrons does this ion have? Well, if it has 20 protons and its charge is +2, then it needs to have more positives than negatives, right? There's a formula for this, though. We could say that the net charge is going to be the sum of the number of protons minus the number of electrons. Okay, that's going to be the net charge. So for us, that needs to be +2. Our number of protons is 20, so we can solve for the number of electrons. It's going to be 18. How does this happen? Well, take your original calcium atom, and let's say that it's neutral. How would we know that it's neutral? Well, you know you have 20 positives in the nucleus, or else it wouldn't be called calcium. So you count up the electrons in the shells, right? So there's 1, 2 in that first shell. Then we got 3, 4, 5, 6, 7, 8, 9, 10, if we include the first 2 shells. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 electrons in this atom. But what if those 2 electrons in the outer shells were to be lost? If they were to leave the atom, that would leave us with 20 protons and 18 electrons. That's one way an ion of calcium can be formed. How many neutrons does this element have if its atomic mass is 43 and its number of protons is 20? It must have 23 neutrons. Now, can we find the net charge on the entire ion in coulombs? For that, we can find the charge on the protons, we can find the charge on the electrons, and charge on neutrons is just 0. Okay, so Q total is going to equal Q of the protons plus the Q of the electrons. And we could put in plus Q of the neutrons, but that's just going to be 0. I'll do the rest on a blank page. Okay, we want to find the total charge. It's going to be the charge on the protons plus the charge on the electrons plus the charge on the neutrons. Charge on the protons is found by multiplying number of protons times the elementary charge. For electrons, it's similar, except we need to make those negative. And for neutrons, of course, the charge on them is 0. So for this atom, we see that we have 20 protons. Our elementary charge is 1.6 times 10 to the minus 19 coulombs. We have 18 electrons. So, Q total is 3.2 times 10 to the minus 19 coulombs. Notice that it's positive, which is expected because this is a positive ion. Let's say you're given a container that has 50.6 grams of hydrogen atoms. What is the total charge on the protons in this container? So to answer this, we're going to look at the periodic table for help. We can see that hydrogen's entry in the periodic table contains just 1 proton for every hydrogen atom. And in the upper left, we have the mass number. This number represents an average for hydrogen atoms. Some hydrogen atoms have no neutrons, but others have 1. Some have 2. So the average would be a mass of 1.00794 for a sample of hydrogen. So this number is also often called the molar mass. So 1.00794 is the molar mass. And I'll give units to it. grams per mole. So we have to define what a mole is. So in the same way that a dozen is the term given to 12 items, a mole is defined by Avogadro's number. It's a lot of items. It's 6.022 times 10 to the 23rd things. Now we should determine how many moles of hydrogen we have in our box. We know how much mass there is in grams. It's 50.6 grams. But we don't know how many moles that represents. And that's what the molar mass allows us to do. So we have a formula for it. The formula that relates mass and moles is M equals N times M. M equals N times big M. M represents the mass of a sample. N represents the number of moles in that same sample. And big M is the molar mass from the periodic table. All right, so let's try to plug in our numbers. We have 50.6 grams. We want to know how many moles that is. We'll multiply by the fact that there are 1.00794 grams in every mole. Now, of course, you can rearrange this formula if you wish. You could put it into this form. So we would have 50.6 over 1.00794. This will tell us the number of moles. It's 50.2 moles in the container. And remember, a mole is a large number of particles. So in order to figure out how many particles we have, we're going to use Avogadro's number in a new formula. This particular formula says N equals little n times N sub A. Here, N stands for the number of particles. In this case, it's atoms. Number of atoms. N stands for the number of moles. And then Na is Avogadro's number. That's that 6.022 times 10 to the 23. All right, let's plug in our numbers. Here is the formula. We have 50.2 moles. We need to multiply by 6.02 times 10 to the 23rd. In this case, the units of that will be atoms per mole. I get 3.02 times 10 to the 25 atoms. So, a lot of atoms in that sample. Finally, we can determine the total charge on these protons using our formula from the past, Qp equals Np times E. There's one thing to think about though. Just notice that we found N, which is the number of particles, or number of atoms in this case. Here we want to put in the number of protons. For some elements, the number of atoms doesn't match the number of protons. In the case of hydrogen, though, it actually does. So for us, note that N is Np. The number of particles is the number of protons. So we'll just do this. 3.02 times 10 to the 25th protons. Okay, we'll multiply that by 1.6 times 10 to the minus 19 coulombs per proton. And we can find the charge now. It's quite a lot. 4 million coulombs. It's a lot considering that for many of the situations we'll look at, we'll be dealing with nanocoulombs and microcoulombs. This would be megacoulombs, which is a lot of charge.